Warning: the following object is probably the absolute last thing you would ever want to run into in the entire universe. It packs a mass greater than our entire sun, but its diameter, a mere 10 to 20 kilometers. Its surface harbors the most extreme density and the most insane gravity in the cosmos, along with a magnetic field capable of tearing you into powder right down to the atomic level. This is a magnetar, an exceptionally rare, extremely violent type of neutron star. It is the corpse left behind after the death of a supermassive star. How is it born? Picture a star 8 to 20 times the mass of our sun. It burns through all its nuclear fuel. The outward pushing radiation pressure vanishes. The outer layers then begin to free fall inward at near the speed of light. The core is crushed to its absolute limit. Iron atoms are pulverized, and electrons are violently smashed into protons in a process called inverse beta decay. Protons and electrons merge into neutrons. Now, the only thing stopping it from collapsing further into a black hole is a quantum mechanics rule called the Pauli exclusion principle. The neutrons essentially say, "Stop pushing. There is no more room." This is known as neutron degeneracy pressure. The star's outer layers rebound and are blasted away in a supernova that outshines the entire galaxy. Meanwhile, its core is locked into a sphere just 10 to 20 kilometers across. A neutron star is born, and magnetars, they are the most extreme handful of these stars. If you could scoop up just 1 teaspoon of material from a magnetar and bring it back, that single spoonful would weigh over 1 billion tons. That is heavier than all the mountains on Earth combined. The gravitational acceleration on this planet's surface is 200 billion to 3 trillion times that of Earth. If you stood on it, your body weight would surge to hundreds of billions or even trillions of tons. Within microseconds, the gravitational differential would smear your body into a film just 1 atom thick. Any mountain taller than a few millimeters on a magnetar would be instantly crushed flat by its own weight. But density and gravity, those are just standard features for any neutron star. The thing about a magnetar that will truly make you despair is its magnetic field. The universe is full of neutron stars, but only about 10% can be called magnetars. In the first few seconds of a magnetar's birth, the violently churning superconducting nuclear matter inside acts like a massive, cosmic-scale dynamo. Within seconds, the magnetic field is pushed to the absolute limits of physics. The magnetic field strength on a magnetar's surface ranges from 10 to the 14th power to 10 to the 15th power Gauss. For context, Earth's magnetic field is about 0.5 Gauss, and that alone is enough to protect us from being shredded by solar winds. A magnetar's magnetic field is quadrillions of times stronger than Earth's. At this intensity, the magnetic field itself has mass. If you converted the energy of a chunk of this magnetic field in a vacuum into mass, it would be heavier than a block of steel of the exact same size. Now, let us say you have a death wish and fly a spaceship near a magnetar. At a distance of 300,000 kilometers, roughly the distance from the Earth to the Moon, its magnetic field would instantly wipe every hard drive on your ship, the credit cards and ID in your wallet, completely demagnetized. For any civilization reliant on electronics, this is already the apocalypse. Get a little closer, to 1,000 kilometers. That is when the real show begins. The human body is 70% water, and water is diamagnetic. In Earth's magnetic field, this means nothing. But in a magnetic field of 10 to the 15th power Gauss, that diamagnetism is violently amplified. Every water molecule in your body frantically repels the magnetic field. Meanwhile, the trace amounts of iron in your blood are violently attracted to it. These two forces would rip through every single blood vessel and cell in your body. Your neural electrical signals would instantly short-circuit. Your consciousness would be snuffed out long before the agony even registers. But the horror of a magnetar goes much further than that. On December 27, 2004, Earth's ionosphere was suddenly blasted by a massive gamma-ray burst. Global radio communications were disrupted, and every satellite recorded the anomaly. Astronomers tracked the source. It was not the sun. It was not the center of the Milky Way. It was a magnetar 50,000 light-years away, designated SGR 180620. The energy released in just 0.1 seconds during this outburst was equal to the total energy our sun radiates over 250,000 to 500,000 years. Physicists ran the numbers. If this magnetar had been just 1 light-year away instead of 50,000, the gamma rays from this starquake would have acted like a cosmic razor, instantly scraping away Earth's ozone layer. After that, ultraviolet radiation would bake all life on the surface into charcoal. You would not even have time for a warning, because the death ray travels at the speed of light. Fortunately, a magnetar's berserk state only lasts for about 10,000 years. The cost of maintaining such a terrifying magnetic field is simply too high. Its rotation slows down, and the dynamo mechanism shuts off. It exits magnetar mode and becomes a normal, relatively quiet neutron star, usually manifesting as a pulsar. It is not dead, just calmed down. So far, humanity has only discovered a few dozen magnetars in the entire Milky Way. They are rare, manic, solitary beasts of the cosmos. We always think black holes are the most terrifying, but at least a black hole has an event horizon. If you do not step inside, it cannot hurt you. Magnetars are different. They can inflict devastating damage from tens of thousands of light years away, disintegrate your biology from thousands of miles away, and rip you apart at the atomic level. And yet, human civilization has somehow managed to survive peacefully in this violent universe up to this very day. That in itself is an incredibly low probability miracle. Let me ask you one last question. If a magnetar was truly hurtling toward our solar system, do you think humanity would have any way to survive? Let me know in the comments section. Hit that subscribe button, and next time, I will take you to unlock even more mind-blowing truths about the universe.